Hello, good morning. Thank you for being here. I'm Damien Sterkers from Broadpeak, and I'll be presenting here quite a hot subject about latency in streaming, in OTT streaming, and how to erase that latency that has been a problem for anyone working in that field. So of course, the use case, we all know it. It's a traditional event, like sport, for example, where you get your neighbors shouting and you're still waiting for the action to happen. It's probably kind of an overstated use case, but it's really getting a problem nowadays that you get social media, right? So very often you're getting a lot of messages, about the events that are coming up. So very easily that can spoil your experience if you get a really poor latency. So down to the subject, where the latency is coming from in streaming. So what you see here is a typical chain when you're using broadcast, so traditional IPTV with MPEG-TS, right? So we see an end-to-end latency that's 5 seconds, for example. It's just indicative, but it's somewhere in that range. Now, what's going on when we're doing streaming, right? Basically, we got two big problems. One problem is the buffering that we have on the streaming players. The other one comes from the segmented nature of adaptive bitrate formats, so what is used for OTT. So I'll get more in details on these 2 points. But first, what I wanted to say is there's a direct link usually between the size of the segment that we decide to set up in our adaptive bitrate configuration and the overall latency. So for HLS, the recommendation is still 6 seconds per segment. For Dash, it's more typically 2 seconds. So what we observe in reality is that the latency issue is less a problem for Dash than it is for HLS, right? But it's just following the recommendations. Actually, you could use a traditional HLS and put 2 second segments and get pretty much the same as what you have for Dash, right? But again, it's a bit less, but we still have the two issues, right? Now, what's interesting is that the bigger problem is on the buffer, right? That's very often when you hear speeches on how to resolve the latency issue, very often this is forgotten, and this is probably the main point that we want to resolve here. So regarding the buffer, what Broadpeak is proposing is to resolve that problem with multicast ABR. So I should probably start by explaining a bit what's the concept of multicast ABR. So multicast ABR is you're taking any OTT system, right? That usually the output point is an origin server, that is getting the request for streaming from the end users through a CDN. And we're adding just 2 components, right? One that we call the transcaster, that's a server that's in the headend and basically will request a certain number of assets that are available from the OTT headend and wrap that into multicast. Once it's in multicast, it can go around the network down to the home network, right? So at once, you got the multicast spreading out all over the network. And in the home network, we're just placing a small agent that will do exactly the opposite, right? So it will unwrap this multicast layer and then make the OTT packets available to any standard device that will be placed in the home network. That includes set-top boxes, right? So in a nutshell, by using multicast, we're delivering the content once for all, right? So very convenient, especially for high popularity live channels. You got 1 million people watching the same live channel, that's only one physical stream on your network, right? As opposed to when you're using HTTP streaming, where you're gonna have just as many sessions, right? Multicast, you can make it go through any kind of network. That could be DSL, it could be cable, it could be fiber. And really the solution is about transportation layer. So you can put any kind of formats, segment formats that you have in your OTT platform. So that could be HLS, that could be Dash, that could be smooth streaming. So how do we resolve the problem using multicast ABR? So the buffer that we have, this large buffer that we got on the players, was never there by accident, right? It's been placed there because of the uncertainty that you get in the HTTP streaming delivery, right? It's HTTP, so it's a best effort and it's irregular, right? So what's the buffer for? Just to make sure that the player always have a content to play, right? So sometimes the packets are coming fine, sometimes they're slower. If they're too slow, slower than real time, you still have your buffer to make sure that you don't stop your stream. Now, when you're using multicast ABR, what's important here is multicast, right? And that's going to work exactly as traditional IPTV, the one with the TS, right? It's multicast, only one stream, so pretty flat here, and it's prioritized. You make sure that the content arrives, is always there, right? So, in the end, here, the buffer you can put on the player is no more than traditional IPTV, right? So maximum half a second, more typically 200, 300 milliseconds. And we know it works. Why? Because we've been using it in traditional IPTV for years, right? So we're going from 10 seconds or something like that, right, or more, to half a second. And it's safe, right? You're sure at any time that your content will be arriving to your player. So now if we look at our picture, we're here, right? We've resolved the problem with the buffering, and we still have this extra latency that is induced by the segmentations of our stream, right? I'll get more deeper into that in the next slide. But, you know, again, something that is very important is that you can reduce that buffer only if you've done something on the network to guarantee that your packets will be there on time, right? So now about segmentation, how does that work? You know, we're always talking about OTT streaming, right? But it's not exactly streaming actually. It's a progressive download. It's a progressive download of little segments, right? So it feels like it's streaming, but it's still progressive download. And what's the impact of that? You know, let's take the packager that you have at your OTT head-end. You got an encoder that is providing data real time, right? So if you got a 2-second segment, what's going to happen is the packager will have to wait 2 seconds before the segment is there, and then can process it to make it available downstream, right? So you're losing 2 seconds here. You're losing a bit also in the network, but I'm just counting this out of simplification. At the level of the player, very often this is real time as well, right? Because if you have more bit rate, usually what the player will do is just switch to a higher layer, right? So same thing, you know, to get all the segment, you have to wait 2 seconds, and then you can pass it out to the decoder that can start displaying something on your display, right? So here, that's 4 seconds that we got. That's logical. There's nothing we can do about it if we're working like this. So the solution with that, and this is something that's quite generalized today, is to use CMAF low latency. What is CMAF? CMAF is a segment format that originally is meant so that we get the same physical video packet for both HLS and Dash, right? And within the specification of CMAF, you're given a way to do low latency. So how do we do that? Basically by sub-segmenting the segment. So here you got 2 seconds. And for example, you can do 10 different chunks inside of it of 200 milliseconds, right? So this is on the video layer. If you go on the transport layer, you have something that is equivalent that's called chunk transfer encoding, right, through HTTP. So we can just match these two. So we're making this 200 milliseconds entity at the video layer and at the HTTP layer, right? Once we've done that, then let's see our example again. What's happening now? Here, I'm starting to get my first chunk, right, of the segment. So after 200 milliseconds. And what's going to happen is, because I've implemented these two technologies, when the player is going to be requesting that content, the system, instead of saying, no, I'm not ready, I don't have the segment, it will say, well, I don't have everything, but let me give you already what I have, right? So you're going to get the first chunk. And because we've implemented CMAF, so at the video layer, the player can do the same, right? let me get this, right? This small chunk that you already have, and you can already display something, right? So basically what we've done is, on the principle, it's exactly the same as before, but we've divided the problem by 10, right? So where we had 4 seconds of delay, we got 0.4 now, right? So if we're looking at the final picture, we've resolved first the problem with the buffer with multicast ABR, and then the segmentation problem with CMAF low latency, right? And we're going down to the same level as what we had at IPTVs. So there are a lot of discussions about latency, ultra low latency and all that, but the most important thing really when you want to implement streaming, especially for live, is to make sure you have no regression against what people are used to, right? So here, you're just making vanish the extra latency that you would have using streaming against traditional broadcast. So you're on par with the existing systems that are deployed today. So conclusion of all that, and I think that's really an element that we should be careful with, is this is the standard use case. What is most commonly found in the industry is you got your standard packager player, the quality is good because you get this big buffer, the latency is not good, right, because of that. Second use case that you'll probably be exposed quite often, but it's kind of a trick, really. You get an optimized packager and player using CMAF, but you have not done nothing on the network. So if you do that, you're shrinking, what people sometimes show is they're shrinking the buffer without having the solution on the network. So the buffer is smaller, but you're never sure that your packets will get there on time. So what we see is the quality is terrible, right? Because it's stalling from time to time. The trick here is it's going to work in your lab, right? If it's just a wire, then you're fine. In a real network, that won't work. So to us, what needs to be done is we got this optimized player and packager, but also we've done something on the network. And at Broadpeak, our proposition is to use multicast for that, right? And then you get good quality and good latency. So that's the end of my presentation. I'll be standing around if you have a specific question you want to ask me. Thank you very much for your attention. Have a very good show. Thank you.